Alright, hello. So this is part 3 of energy and changes in matter, skills practice number 6. So number 1 is how much energy is required to change temperature of 210 grams of water from negative 40 degrees Celsius to 155 degrees Celsius. The first part is ice, so there's no phase change, so you use Q equals mc delta T. You know your mass, your C value is 2.06 because it's ice, and your change in temperature is 0 minus negative 40, so you get 40, and you get 70,304 joules of energy. Next part is fusion. Since it is a phase change, you use Q equals m delta H. You know your mass, and your delta H of fusion is 334, so you get 70,140 joules of energy. Liquid, there's no phase change, so you use Q equals mc delta T. You know your mass, you know your C value for liquid is 4.18, and your delta T is 100 minus 0, so you get 87,780 joules of energy. Vaporization is a phase change, so you use Q equals m delta H, so you know your mass, and 2,260 is delta H for vaporization. You get 474,600 joules of energy. Steam is Q equals mc delta T because it's not a phase change, so you know your mass. Your C value for steam is 2.02, and your delta T is 155 minus 100, so you get 55, and you get 23,331 joules of energy. And to find the total energy, you add them all together, and you get 673,155 joules of energy. Part 2 is how much energy is required to heat up 45 grams of water at 55 degrees Celsius to steam at 140 degrees Celsius. The first part, it's in a liquid, or it's a liquid, so you use Q equals mc delta T because there's no phase change. You know your mass of 45, and your C value for liquid is 4.18. Your delta T is 100 minus 55. You get 45. You get 8,464.5 joules of energy. Next part is vaporization. It is a phase change, so you use Q equals m delta H. You know your mass, and your delta H for vaporization is 2,260, and you get 10,700 joules of energy. Next part is steam. It is no phase change, so use Q equals mc delta T. You know your mass, and your C value for steam is 2.02, and change of temperature is 140 minus 100, so you get 40. So multiply them, and you get 3,636 joules of energy. And to find the total energy, you add them all together, so you get 113,800.5 joules of energy. Part 3 says, consider a cup of coffee that has a temperature of 93 degrees Celsius. Assume that the mass of the coffee is 550 grams and that the specific heat of coffee is about the same as the specific heat of water. Is a 230 gram ice cube at 0 degrees Celsius a large enough ice cube to bring the temperature of the coffee to 23 degrees Celsius? And it gives you a hint that the final temperature of both the ice cube and coffee is 23 degrees Celsius. So for the coffee, because it's a liquid, so there's no phase change, it's Q equals mc delta T. Know your mass is 550 grams. Your C value for liquid is 4.18, and your delta T is 23 minus 73, so you get negative 70. So you plug that in, you get negative 160,930 joules of energy. And the ice is Q equals mc delta T because there's no phase change. Your mass is 230 grams. Your C value for ice is 2.06, and your delta T is 23 minus 0, so you get 23, and you multiply that, and you get 10,897.4 joules of energy. So no, the ice cube is not large enough to bring the temperature of the coffee to 23 degrees Celsius. The coffee is at negative 160,930 joules of energy, and the ice cube only provides 897.4 joules of energy, so it would not bring it to 0. Question 4 says, consider a pot of water at 100 degrees Celsius. If it took 1,048,815 joules of energy to vaporize the water and heat it to 135 degrees Celsius, how many grams of water were in the pot? Okay, so this is Q equals mc delta T and Q equals m delta H. So because it's vaporizing, it's 2,260 times the mass, so that's in the first bracket. The second part is your mass times 2.02 times change of temperature, which is 35, since it's steam. And you set it all equal to the Q value that is given. And basic algebra, and solve for m, which is 450 grams.